Hi, this is Cliff Brake from Beck Systems, here today to discuss synchronization support recently implemented in the Simple IoT project. This is a big feature, one that's taken us a while to get finished. But it's also one of the core features of the project that gives us the ability to synchronize data between instances. And really we view IoT system as distributed systems where data needs to flow both directions. So let's look at a demo of this. So we have three instances, and let's log in and give these names. Okay, the first instance is the edge instance, and that's this embedded Linux computer running over here, talking to a Modbus I/O module and several Modbus temperature sensors. And let's call that the server instance, and then a cloud instance. So typically an edge device could talk directly to the cloud, but in this case we're going to add another hop for demo purposes. So to connect the edge to the server, we'll add an upstream instance, or a node. And let's call this upstream to server, nats. And once we create that node, it should show up here in a few seconds. So now if we would add a variable, we'll see this variable show up over here. If we make changes, those changes show up here, and we can modify it both places. So now if we want to synchronize everything up to the cloud, we'll add yet another upstream. And again, after a few seconds, we should see it show up over here. And we can turn things on and off up here as well as down there. So we can make configuration changes if we add another variable at the cloud. Notice this variable also gets created on all the instances. The way the synchronization works is if one of these parameters, we call them points, changes, only that point is sent. So if we change a point, one point on this node, and let's change another point on this node, if we save them at both times, both roughly at the same time, then we'll see 25C across all these nodes. So now we see 25C. So we only send the point, and that allows, if an edge instance is modifying sensor values and someone in the cloud is modifying a config setting, then those points can flow both directions and there's no conflict. If the same point is modified on two instances at roughly the same time, the one with the newer timestamp will win. So that's synchronization in a nutshell. Again, we can change any of these things on any node and they'll catch up. So the other thing, this is real-time synchronization when everything's connected, but if one of these nodes would be offline for a while, then once it comes back online it needs to synchronize. So let's turn off the server node for a few seconds and make a few changes here. Let's change this to 205 psi. Notice these aren't being synchronized right now because this middle node, which provides the link between the two, is offline. So if we fire this back up, a few seconds, things should synchronize up again. Yep, we see 205 psi down here. And the way this works is we organize our data in a tree of nodes, and each one of these nodes has a hash. And the hash basically tells us if anything that in that node or any of the child nodes have changed, the hash changes. So to know if we're fully synchronized, we just compare the hash for this edge node and this node here. If those hashes match, we're synchronized. If not, then we need to walk down the tree and look for changes. And this technique is called a Merkle tree or a hash tree and is used in quite a few different projects. The Git revision control system uses Merkle trees, as does blockchain and cryptocurrency, as well as distributed systems. It's a common technique. So the last thing I'd like to show is more of a real-life demo. And let's add a few Modbus devices to this edge node. And let's add 2 IOs. This first I/O is going to be an input that's attached to a switch. And the second I/O is going to be an LED attached to an output. So now if we flip the switch on, we'll see the switch turn on all 3 instances. Flip it off, it should turn off. Flip it back on, turns on. We can also turn on the LED from the cloud and turn it back off. And again, if we have local access to the edge instance, we can manipulate everything directly right there. So that's Simple IoT synchronization. Quick overview. If you have any ideas or feedback, feel free to contact us on our GitHub projects or the TempDir discourse forum, where we hold discussions, or you can reach out to me directly. Thanks for watching.